Fantastic. There we go. So, a bit of a late start, so I guess we will be also a little bit late with our session. I will try to keep the introduction a bit shorter to save some time, but I can't promise. I'm really happy that you have chosen our session, and I see a full room, so I'm very happy about that. Let's see if the clicker works. Yes, and it's the same deal as all the other sessions. You can ask questions using Slido. It's this room, Barcelona. Please use the QR code. It's the same QR code that's on this slide. I'm just framing the session for the other speakers, giving a short introduction of semantic interoperability in EOSC and beyond. And to start with, the idea for EOSC here is to have this connected web of data and services, or research artifacts more generally, perhaps. We need something to augment our data to make sure that you can really preserve the meaning of what does a name, which is just a string of character, actually mean, and what does it represent in the wider context, more of an abstract concept, and how does that link to places or other generic concepts that could be important to do large-scale queries across different domains and services. This information augmented, the data augmented with these conceptual models can help you translate across different services and perhaps also support data integration. So interoperability across tools and services is the key. EOSC, I would also say, is all of us, which means that this is something that we should try to adopt as a community. It's not just for the sake of EOSC, even though in the Strategic Research and Innovation Agenda and the MAR, the Multi-Annual Roadmap, there are some really good priorities that we could also use as a focus for our own communities and with our own institutes. So on the EU level, there are support for making investments in creating these kinds of standards and agreeing on common conventions. There's on the national level also some suggestions for supporting and highlighting the infrastructures that, or the frameworks that set the prerequisites, and then also on the institutional level, there are some guidelines on what you can support. In the context of EOSC, I would say that for semantic interoperability, it makes a lot of sense for your own research groups. It's a lot simpler there. You have agreed formats and conventions. You know what the data mean yourself. But it's starting to get more challenging when you're talking about someone else's data. And then you might need contextual information that describes both which standards you have actually used and some quality assessment or other assessment information about where the data is coming from, by whom, and under what circumstances it was collected. And in the European context, you have a wide flora of different kinds of data formats, terminologies being used across many different disciplines, I mean, finding a way of just making sure that people know what to use, how to translate across these is very important, both within disciplines and larger communities and across EOSC as a whole. You could consider that the web can be represented as a graph in a sense, where the nodes represent data or these research artifacts, anything being created by research and potentially being interesting enough to be shared for the wider community. So each node here could represent an artifact that's encoded as data, some sort of digital file format with metadata describing how it's related to other research artifacts. And you see a lot of pictures here, a bit abstract, but I mean, you have a DNA sequence there, and there are conventions for encoding that as data formats, and there are conventions for linking that kind of information to sample information, to experiment information, and there are similar conventions across other domains. You need a way to kind of agree on what level of detail do you have in a graph like this to be able to provide meaningful search results for search engines across EOSC, and also if you want to make a query across disciplines, you need to have some common abstractions to agree upon, so you can navigate this in a sensible manner. And throughout this set of presentations, we're going to highlight some projects that might be interesting working in this direction. We're also going to encourage you to contribute to share your own initiatives and projects that you think are relevant to solving these problems. And there's a document that's open for comments in the description of this session in the EOSC program on the website. So if you go back there, you can then add your own projects and contact any of the speakers to suggest that we get in touch with you. So this is the FairCore for EOSC project, and they're working on a PID graph and other graph-like structures to kind of facilitate creating graphs like this. And then also sharing data across different communities. You can start with your own research groups and wider institute or community, and you might need some practical solutions to package different kinds of research artifacts together with the metadata that describes which standards are being used and the basic information about the context where these were created. And there's a solution called the RO Crate, which has been adopted across a wide range of different communities. That might be an interesting option to look into. There are other solutions as well, and some of them are also listed in this shared document and will be highlighted across the other presentations. And then in the EOSC Semantic Interoperability group, or task force in the EOSC Association, we are doing a survey at the moment looking for different practices of describing and sharing information about data. So if you're interested in highlighting what you're doing in your community, please reach out to us. And Kurt Baumann, and his email address is also listed in that document, and he's in the room. So with that said, I have saved, I think, almost 1 minute. The last slide here is just an overview of the program. So we have 4 more speakers, and the Q&A will be during the panel session. So thank you, and I'm leaving over to Jian.
Do you mind leaving your laptop? That's okay. Thanks. So, good morning, everyone. So my name is Yann Lefranc. I'm involved in working with Kurt and Walmart in the EOSC Semantic Interoperability Task Force. I'm also involved in the Fair Impact project, which is the sister project of FairCore for EOSC. And this morning, I'm going to talk about semantic artifacts and their representations. So I'm trying to give a brief overview of what semantic artifact is and what are the different formats for representing a semantic artifact. And I would like to start with a simple question: is what do semantic artifacts represent? In the end, the semantic artifact represents the conceptual models that Walmart was mentioning. And here I'm showing an example which relates to what happened yesterday night, right? For those who noticed. So it's the beer ontology, right? And the idea is that you want to describe a part of the world, right, with the concepts and the relation that interlinks the concepts together, right? So here, in that case, well, you have concept like beer, which is associated with ingredient through a relation, has ingredients, and within the ingredients, you have all the list of the different ingredients, yeast, hops, grains. You have also the brewery concept that's actually allow you to link a beer to the brewery who actually produce the beer and so on. And so that's a conceptual model, and you have a classification on the other side, which is a taxonomy of beers, where basically you have hierarchical representations of the different kinds of beer and how each individual beer is associated with it. Sorry. Now, semantic artifacts can come in very diverse forms, right? So they can be extremely simple, and I think one of the most simple is what we call the code list. So you can think about zip code lists or the list of countries, which is just a flat list that contains some information, so human-related information, right? It does contain some semantics. Now you have diverse, different types of structure that can be built. So you have controlled vocabulary, which is an authoritative list of terms. So basically a group of experts agree on a list of concepts that applies to their domain and provide proper definitions so that others can reuse for annotating their data. So all these models are here because you want to actually explain the structure of your data and what it means, right? Though you have the thesaurus, for instance, which actually links this control vocabulary and the concept in this control vocabulary with potential synonyms, so you can cope with the diversity of naming conventions between different communities. So here you have the examples for proteins and disease. You have the taxonomy, which is a hierarchical organization, and we saw that with the beer. So you will classify the concepts in a hierarchy. You can also add up synonyms, and then you can actually have more complexity. And then in the end, you have here, it's called an ontology. I would call that more a formal ontology, where there you have, like in the beer ontology, you have a hierarchy of concepts that can be interlinked with relation that actually convey logical meaning as well. And this is a slide that has been taken from a previous presentation from my colleagues from Fair Sharing that Susanna is going to talk after. So here are some generic examples of conceptual model, like very generic ones. So you have DCAT, which is a conceptual model that describes digital collections of data sets. You have PROV, which is a basic model to represent provenance information in a standardized way. You also have another one that's well known, that's Dublin Core. And here it's just one part of the model, which is actually the most simple one. But behind the scene, you have a more complex one. You have also the friend of a friend conceptual model that actually describes people and the relation between people. Now, what are exactly semantic artifacts? So this concept comes from a previous project I was involved in, which called Fair is Fair. You may have heard about it, where we try to come up with recommendations on how to make ontologies, controlled vocabulary, and all these artifacts fair. The problem is when you start talking about controlled vocabulary, thesauri, then you enter a debate whether or not it's an ontology, not an ontology. So we tried to extract ourselves from this debate, and so we created the semantic artifact, which is defined very precisely. It's the machine-actionable and readable formalization of a conceptualization, which enables sharing and reuse by humans and machines, right? So these artifacts may have a broad range of formalization, so it can go from very simple semantics, like a code list, to formal ontologies. And they have different serialization format, and that's what I'm going to talk about now. So here is a plain list, it's certainly not complete, of potential formats in which you can find semantic artifacts. On the left side, you have the different models that allows to describe this artifact, and on the right side, you have the syntax that you can use. So XML, JSON-LD, RDF XML, Turtle, PDF sometimes, for which, well, of course, is not machine-actionable, you can imagine. Now, I wanted to have a short overview of the practices in communities. So it's very, again, it's not complete overview, it's not a full landscape analysis, but working with colleagues in different domains, for instance, here in biodiversity and environmental science, if you start looking at the ontologies or thesauri that exist, in GBIF, for instance, you have a very extensive list of concepts. They are all encoded in XML. Now, if you go to LTER vocabulary with the ENVTES, which is environment, well, it's coast-based, right? And you can find it as a Turtle. Now, you also have the environment ontology, which is then an OWL ontology. So within the same domain, you have a diversity of representation of the semantic artifacts. Same goes for marine. So Alexandra may talk about the NERC vocabulary service, which is a service that provides SCOS vocabularies. If you go to AgroPortal, then you can look that you also have a mixture of OWL and SCOS in the agriculture community. Same goes for OboFoundry, which is biomedical list of ontologies. These ones are all OWL. And then if you look at BioPortal, which is one of the biggest resource of ontology lists in biomed domain, so you see that you have a mixture of OWL, SCOS, Obo, which is a OboFoundry specific language, and even UMLS, which is really specific to biomedical. Same goes for linguistics. Here in linguistics and humanities, you have more harmonization. It's most often SCOS, so if you go to the Clarin-Clavas vocabulary service, it's SCOS. The CESDA vocabulary service, most of the vocabularies are in SCOS. If you go to the SHOC vocabulary service, it's all in SCOS, right? There was also a project that we started looking at an in-depth landscape analysis, which is OntoCommons, and the project is working on the field of material science and manufacturing. And there we found some interesting results. So most of the ontologies you would find in domain are OWL, but a lot of them are just PDFs. So they are just papers describing the ontologies, and that's it. You cannot find a machine-readable or machine-actionable version of the ontology, so you can't work with it, basically. And it will cost you a lot to actually re-implement that. And in terms of serialization, well, you have different flavors, so you can have that as RDF XML, OWL, Turtle, multi-syntax. And I can invite you, you have the link to the deliverable if you want to know more on that landscape analysis. So basically all these semantic artifacts are very important because they are part of the standardization landscape. And this is a report from the Observatory of ICT Standardization, so the European Observatory, where basically you have a long list of ontologies from different models, different representation. Now it's nice because you can get that list, but the problem is you have seen you have a large diversity of representations, and now if you want to think in terms of interoperability between the systems, then you start having troubles because, well, OWL does not necessarily work easily with COS, right? So if you want to integrate things together, then you start having issues. And you will have difficulty to find the ontology, although here I know where to find them, but to interpret and reuse. So how can we resolve that situation? One way we try to do it is actually by thinking, okay, these artifacts, we should apply the FAIR principles. This is a nice framework to start thinking about harmonizing the practices. So I invite you to read the deliverable. You have the GOI here, it's on Zenodo. Basically, we came up with 17 recommendations. We also classified them whether they should be a must, a should, a may, with the communities. And basically, to summarize, well, it's simple. You have to use globally unique identifier for the ontology and for the concepts and for the relations. You need to have a minimum machine-readable metadata. You need to use a repository or a catalog of semantic artifacts. That makes the link with the next. And then use common APIs. And then finally, publish these mappings and crosswalks when you start linking these ontologies together. And I will stop there. Sorry.
Thank you very much. Okay, so I'm switching gear a little bit. I'm going to focus more on the catalog and the registry of the semantic artifact and any other artifact for data metadata, as Wolfram mentioned earlier. So I'm Susanna Sansone from the University of Oxford. I'm also part of several EOSC projects, including the EOSC FAIR Metrics and Data Quality Task Force. Okay, so in terms of what type of catalog there isn't really a kind of, detailed classification. This is a very broad one to really understand generally what functionality do they have. We have resources like the metadata standard catalog, part of the RDA, which is more at discovery level. It's where you can find things. But then we have resources, for example, like for sharing, also part of the RDA, which goes deeper because doesn't really just allow discoverability, but also allowed accessibility, explain conditions, status, relation of the different semantic artifacts and other type of standard and like syntax standard, for example. So it offers more functionality, goes deeper, although it's broader, it's not just for semantic artifacts. And then we have obviously resources which are specialized in the semantic artifact, not just to make them discoverable and findable, but also to make them more usable at term level. So they have functionality like, sometimes allowed even the creation, the merging, the annotation, and so on and so forth. And one example is the bioportal. I'm going to go a little bit more detail later. If we now look very generally again at the sustainability aspect of this registry, of this catalog, we know very well the problem is the problem of any other resource. It's about the content, maintaining the content up to date. Are the right semantic artifact the community use? Are they there? Can they grow? How can you assist the user in terms of content? But also technically, we will see, I have one slide showing example that some of these registry are simpler than others. So even maintaining them or, evolving them and updating them can be complex in many cases, or can be simple in other cases. Embedding, I mean, making the content then accessible to other tools, to other resources, so they get more connected. That's a feature that, require a lot of effort, and getting the resource then endorsed. And obviously, everything it's underpinned by, you need to have people with the expertise to do all of the above. Excuse me. And you have to have funds, as we know, to do and support and grow these resources. So if we look at software diversity of this, different registry and catalog, that also includes semantic artifacts, they are also very different. So a great example to the lowest level, the one where you actually can search the semantic artifact, you can use them, you can, even do mapping and etc. It's the OnToPortal Alliance that brings together all the different portal for ontology. And that's important because this same software has been then deployed by different community and make them specific for their own type of content. And the idea is to share the source and the code and the functionality, which then when it comes to sustaining the resource, especially from the technical viewpoint, that's obviously, things get simplified. Then resources like sharing, for example, which again, it's broader in content, has also a lot of technology behind to make the resources themselves fair in terms of discoverability by machine, not just by human. But then you have, excuse me, resources like, no, sorry, it's just stomach, it's nothing, thank you. Then you have, too much coffee. Then you have resources like the metadata standard catalog, which is simpler, GitHub-based and API, not much than that. So it's simpler to maintain, but offer less functionality. And this is, the usual balance here. Let's then look a little bit of another challenge, which is the governance. And I just want to thank Dan for providing me the example and the material for showing an example from the Clarence community of the challenge they have had and now they've tried to overcome. So Clarence's goal was to make the metadata profiles and the language in the data explicit. So use of semantic artifact, it's obvious the way to go. But how to put together all this information, what resource to use. So Clarence started working with the ISO Technical Committee 37 and started using their catalog, which is the ISO CAT, the Data Category Registry. Now, in these 4 bullet points, there are the key challenges that the Clarence community found when they tried to use and work with ISO and use the catalog. So first of all, the model is too complicated, and the process is very formal. The procedure from ISO are complex. If you are part of an ISO community, you actually know that. Adding or even changing or editing the concept, it's also can be cumbersome. The category, so the semantic artifact in the data model, don't necessarily map to the concept that Clarence wanted. And that's where the changes and the work with the expert is required. But the working was really very demanding and was certainly useful in terms of experience, like Dan said, because you learn what does it mean to work with another organization and then work with your expert and address the need of your researcher when it comes to semantic artifact, what the cost and the effort are. And obviously one other important challenge is the culture clash between a grassroots organization with a formal organization like ISO, and also the fast and dynamic need of the research community versus maybe something more procedural and slower like ISO can be, for their own reason. So the choice of the Clarence community was then to move to create the Clarence concept registry, so their own registry rather than leverage on the ISO one, but based on that experience, look for a more pragmatic and a more expert-driven, approach. So the ontology is more pragmatic, and it's really built using the expertise within Clarence and has an editorial board with national coordinators that deal with the content, because an ontology or a semantic artifact, it's not something you build and then it's done. You always have to keep evolving it, deprecating the term, merging the term, adding a new term, discussing the definition, relations, especially if you go in a richer semantic artifact. And so that's all it's done. through this national coordinating and the forum that bring the expert together. And then the group has also done guidance and approval so that people know what they need to do if they have a new request. And so the importance of community involvement, it's obviously challenging too, comes with its own challenge of managing the community and then sustaining it. And what Dan also make very clear that, you know, this also shows that technology sometimes is not the problem. The real problem is the social engineering, you know, behind a certain activity like this one. So thank you very much, Dan, again. And a couple more slides talking about the challenge of cultural clash, especially I've mentioned ISO, I've mentioned the grassroots. This is a slide that I've had for the last 15 years, trust me. You can look back in my slide, 15 years. Nothing has changed. So you have the standard organization like ISO, many others that developed either semantic artifact or other type of standards. And you have the grassroots community. They come from EOSC, they come from other areas. There are examples from the life sciences, examples from the astronomy community like IVO. But more or less, the community works together on designing, formulating, developing, and maintaining the standard or other type of artifact. But obviously what we realize that sometimes the clashes is in the culture, is in the process as well. And just very briefly, I want to show this difference. You know, the proper standard organization tend to develop things at industry level. They tend to be more driven by regulator. And the participation, it's often regulated. You need to be a formal member. You'll sometimes be elected at national level to sit in one of these technical committees. So everything is more formalized, perhaps better documented because they actually make money, either for a fee they license a standard or you have to pay to get the training. You have all the grassroots community that do develop things for free. And everything it's a research level, driven by the need of the researcher, by new technology, by a new data type, by a new community. It's all volunteer. They are free, but that's why you have less documentation, you have, you know, more challenges in that sense. Okay, but there is positive. There are examples where, you know, you have been able to work with a community like ISO. This is my almost last slide. As part of the fair sharing community, we have been able to work with the ISO technical committee, in this case in the life sciences, where they have put together a specification that you buy for a fee. They list all the standards that they have recommended. So existing standard ISO recommends, which is quite unusual for ISO. But the problem is the document is static. You cannot see in a table anything at all. You don't understand the relation to the standard. You don't understand the status. By the time the document was completed, some standards were already not active anymore. So what we did with the fair sharing registry, we worked with the committee to make the live representation of the standard within the specification so that you have a live, up-to-date that will live beyond the static document and offer obviously more information that the document can't to a user community. So a lot of issue, long-standing issue, governance being one, technology being another. I personally have been working myself many years in ontology development, standard development, and the challenges are all the same. These are very, very old paper and reporting and document that mention the same challenge we still face. The governance being a major one. Ownership, when you start working with a commercial partner, and this paper, for example, it's working with the pharma, and they want to co-develop ontology with you, becomes really very challenging also for them to be able to even share the type of area they need to cover because it's proprietary perhaps, but they want to do because they want to use your same terminology in-house so that they can do data integration. So there is a lot of interest in having a shared vocabulary, in having this mapping, in having all this interaction semantically, but it comes with a lot of challenge, which we all know and have never been really properly addressed because they are major. And the last slide is to show a lot of activity which are already happening in EOSC, and this is not a comprehensive list, it's actually not even a list, just example of, for example, in the EOSC impact, and thank you, Clement, for flagging these, there will be a workshop on the governance of these artifacts next week. There are several activities around artifact and standard, obviously many projects of EOSC, especially the new ones, so there is no list because I couldn't even know which name to put in there. But also this is very important in the oh God, what's the name? The EOSC Fair Metrics and Data Quality Task Force, because the use of semantic artifact and other standards is essential in the evaluation, and this is something we are doing that task force too. And this is my last slide. Thank you.
So back again to, what are they, semantic artifacts, because mappings and crosswalks demand their right. There's proper semantic artifacts, they need PID, and they want proper metadata, correct? Hello, good morning. I'm Dan Broeder. I'm affiliated with the Clarin ERIC, which is the research infrastructure for language data and language technology, making them available for research. I have been, in my life, yes, I can say that, working for lots of research infrastructure projects where working on metadata infrastructure was always a big part. And it will not surprise you that much of what I will tell you and how I see things is from that perspective. So I'm not an ontologist, but I'm more a metadata person. Okay. Talking about mappings and crosswalks, I think this is, let's say, not everybody agrees on what's actually meant by crosswalks and mappings. And even in the group that is organizing this meeting. So it's perhaps good if I explain a bit what at least I understand with mappings and crosswalks, and also put it in the right context. So on the slide, what you see there are two botanists, one beginner and one already a bit more, on the road of being a full researcher, making observations and recording those observations in what I call descriptive systems. One such descriptive systems is a map, maybe an Excel sheet, where she is recording her observations. The other is using an XML structure. What is it that we want? What do we want to achieve by mapping and crosswalks? Well, that is trying to get a coherent view, not on one, but on all these descriptions. So what do we need to do that? We have to make these descriptions comparable. So we have to relate the entities, I call them entities, that are in the map and in the XML file with one another. There are a few levels in describing these relations. One is structural. You have kind of map the structure of the table on the structure of the XML file. Next to that, there is the matter of naming. In the map, you name the columns, for instance. So the columns each have a name. In the XML file, you have entity names and you have attribute names. So these two have to be related to one another. And then still there is the matter of the values. People are inputting values in the table cells and as attribute values. So these things also have to be related with one another, right? So there are quite a few levels that play a role here, and that should be all be regarded as part of a mapping there. Before I forget it, of course, sometimes there are value schemes implied in filling in values in a table cell. For instance, you fill in a time format. Well, there are multiple time formats available, and you have to make sure that what you fill in as a time in the one also can be translated to the other. And the relations themselves, by the way, these can be pure equality, or they can almost equal, or broader or narrower. These all have implications for how far you can really bring these things together and with what precision you can make, analysis about this. Okay. Next. I think I forgot something. Of course. What's a crosswalk? A crosswalk is a set of mappings that is meant to translate at maybe the whole description, or at least a big part of that description, from one formalism into another formalism. Okay. Mapping examples. The most simple example I can come up with is simply a table where you have the concepts that are used in one description system, in one column, next to those in the other description system. And a table like that implies pure equality, right? And that's probably not enough for what you want, but tables are really a powerful mechanism because you can add other columns. For instance, you can add the column where you add the type of relation that's there. I already mentioned almost equal, or broader or narrower. You can add more metadata that pertains to this particular mapping. So for instance, justification. Huh? Why do you think you can make this mapping? Provenance information, all fine and all simple and all manageable by using tables. On the other end of the spectrum, things that are much more complicated, at least from my perspective, is using hierarchical annotation systems like XML, like JSON. So some communities do this for a metadata format, and this introduces additional context for the entities that are in that hierarchy. Additional context that has also bearing on the semantics. And if you want to translate from one such a formalism into another formalism, you can have huge challenges in creating the code that actually is able to do it. A popular way of doing it is using XSLT, which is specialized to translate from one XML file into another XML file. The useful mappings and crosswalks, main purposes. Well, in my experience, aggregating and integrating data sets for further processing. You translate what you harvest, for instance, into a, let's say, well accepted metadata format, and you aggregate everything, and then you can search as if it was all coming from one source. So this is searching after converting. Another way of using it is you can leave the sources as they are in their heterogeneous format. But if you want to query in that, you can still use the mappings to do query expansion. This will allow you keep using your own terminology and find what you actually need. So crosswalks do also not always need to be complete, just need to achieve their maybe project limited purpose. And many researchers use experimental mappings, so things that are just interesting for their project at that particular moment. If you decide to archive those mappings, those crosswalks, you better make sure that you add that information to the archived mapping. Note also the difference between modeling and only specifying relations and actually converting data. Because what you need to do then is to collect all the mappings that pertain to the relations between the schemas and put it into code. Yeah. How much? I'm already... Nothing? Come on, one more slide. Yeah, okay, let me say something about tools in general. So, we all can imagine researchers, data scientists working hard, filling in Excel sheets to create those mappings, right? Maybe some of you have some experience there. But what we really want is, of course, comfortable tools that will help you create those mappings. Now, you want those tools to be automatic, semi-automatic. I know some of them, for instance, onto Portal, it was already mentioned. If you upload an ontology in onto Portal, it makes some suggestions based on string comparisons for some new mappings. I think the way you map, you compare those strings should be domain specific. I'm sure in the humanities, just comparing the string itself is not sufficient to get a good output there. Other ways of building tools that can help you is to create a proper graphical user interface that visualizes the schema, the two schema, in a good way, and that will allow the user, maybe making use of some background information like thesauri, for instance, that are abundantly existing, to create the right relations between the entities from the schema or the ontologies. Good examples exist there. When we were creating the SEMAF report in 2021, we made an inventory of such tools, and yeah, you will find reference to those tools in the reference page, so you will have something to do. I should say that the Faircore for EOS project, which was already mentioned, is working on such a tool, the metadata schema and crosswalk registry. It will have a graphical interface to exactly create mappings the way I described. It will also test out the MSCR in a number of demonstrators and a number of case studies in collaboration with a few communities. What I think myself is interesting, those demonstrators will try to help people that are working with schemas for very general data management tools like B2Find, like B2Share. Some of these tools must be familiar to you. I know it's so hard work because these tools have to deal with very many community metadata schemas, and I think we will demonstrate that the MSCR will really help the crowd that is maintaining those schemas in those tools. Yeah, is helped by the MSCR. Okay.
Hello, everyone. Thanks, Dan, for really introducing nicely my talk. So I will talk about implementation examples of what you have been talking previously. So we have to practically do the work for providing semantic interoperability in the FAIRIES European project. So we want to provide semantic interoperability on multidisciplinary data that come from various sources. The domains are the Earth environmental dynamics, the environmental biogeochemistry, and biodiversity and observations domain. As you said before, Dan, we want to provide semantic interoperability both to discover data and metadata, and to harmonize data and metadata. And a note here to people that may not know that metadata records of the same data set contain semantic artifacts that are of low granularity, while data sets contain, if they contain semantic artifacts, they are of high granularity level. So to be able to do this job, we have been using all the building blocks that you have been referring to in this talk. So we have been using semantic artifacts, but mostly to provide semantic interoperability, we will use crosswalks, for example, between metadata standards from, for example, ISO 19139 or DCAT to ISO 19115. This job has already been done by a broker called GeoDub. So we already have that. And we are looking into creating mappings between semantic artifacts. And our approach is to avoid the tedious process of creating manual mappings between one term to the other that is very time-consuming and very tedious, and try to semi-automate that, because I don't think you can actually automate it. You have to always have the domain expert to validate the mapping, and then use, as much as we can, mapping frameworks like the iAdapt that we use extensively that actually can automate the mappings. So syntactic interoperability with the crosswalks and semantic interoperability with the mappings. So after analyzing the data record, the data sets and the metadata records from all the sources that are on the right, the values we found are strings that are like oceans, inorganic chemical composition of sediment of rocks, FCO2, that we don't know if they come from a vocabulary, from an ontology, from anything. They are just strings. We also found, in the best case scenario, URIs. Sometimes we also find codes that resolve to nothing, and a combination of strings and codes together. So the work that we have to do to identify semantics in XML documents that have XML snippets like this is quite daunting, and that's why we decided to develop the semantic analyzer that focuses on a set of metadata elements. So currently we are focusing on keywords, parameters, units, platforms, and sensors, and analyze these strings to see if they come from, they are actually semantic artifacts or they're just strings. The design of the tool is, of the semantic analyzer, it accepts metadata records and data files. Currently, it programmatically extracts terms, and it matches them with a knowledge base that includes vocabularies, ontologies, semantic artifacts that come from like various sources, but also metadata models. Currently, we are on that side of the diagram. And after we identify the terms, we want to implement the vocab guesser, which will provide mappings between the semantic artifacts. And then it will provide an output of the estimates, and the domain expert will actually validate if the mappings are OK and publish them. The semantic analyzer looks like this. So it accepts sources of data sets, and it gives XML metadata records currently, and the sources and the XMLs come from the GeoDub broker. They are already harmonized, and these are preliminary results. So the broker looks at, the analyzer looks at a search term and tries to find a matching term in the knowledge base. The knowledge base is really a triple store that has a sparkling point on top of it. And these are some of the semantic catalogs and some ontologies and semantic artifacts that we have there. Our next steps is to enhance the knowledge base with more semantic resources as we learn. I'll skip that one because I didn't talk about it. And we want to enhance the semantic analyzer with data sets because we are currently looking at metadata records, and implement the vocab guesser. I don't know how much time I have. Yes, you have 2 minutes. OK. So, and as a final slide, I wanted to show you a work that we've done in the past with the Sensei Ocean variable demonstrator that showcases the smart mappings, the automatic mappings using the iAdapt framework, where we actually managed to harmonize the parameters of very different and diverse research infrastructures that are here, using the iAdapt framework and actually managing to go up and down the granularity scale of parameters and asking whatever we're wanting and translating it to the language that its research infrastructure understands. If you want to know more about that, I will be out at the coffee later on. Conclusions. Complying to a standard doesn't really make you achieve interoperability. We need to have community profiles to be able to provide interoperability. Semantic resources need standardized referencing from the metadata record, so I've included an example of how to reference a semantic artifact from a metadata record that actually points to the right places. Semantic mappings are a way to provide harmonization, but as we said before, they are very tedious, and frameworks like the iAdapt can actually provide the automated mappings and the sliding up and down the granularity scale. Thank you.
Very well. Thank you very much to all the panelists for the outstanding presentation. Normally, the time is over for the session, but I would like to take a couple of questions. We have, I'm sure that we have some questions, Slido, but I would like to start with you here in the room. There are some questions? Yeah, perfect. Well, the first question concerning the EOSC and how check if semantics is used in EOSC, and thank you very much, and how to propose our semantics. Please, panelists, you can join this, me here probably, or who want to answer the question? The first one concerning the EOSC and how to check if semantics is used in EOSC. No idea. Semantic analyzer.
I mean, yeah, there are tools that you can, we can start using to identify if you have these strings, where they come from. We are building the semantic analyzer, and it will be freely available when we finish that through the Fairies project.
Well, I think that there is a really important question concerning skills and training. The last one, should metadata and semantics be taught as part of master courses and PhD? Yes, of course, but would I?
Yeah, that's definitively a good point. We've seen some training at the university for that. I've been doing some of it myself for a little while, and then, so that's topics that we need to move on and activate a little bit. Like now we do AI by default. We need to do symbolic AI by default and introduce those concepts to students so that they can get them if they're actually going to deal with data science work on with semantic aspects. Yeah, so for sure. And, yeah, and he's also doing some training now also.
Yeah. Well, I think that we can take a couple of questions here from the room. Question? Yeah, there. Okay, thank you.
Hi. Thanks for the great presentations. I have a follow-up fun question. How is the beer ontology related to the wine ontology and related to the pizza ontology? But a bit more serious, actually. What kind of level of expressivity do you expect for solving the interoperability issues? I mean, the mappings can be very simple. It's just one-to-one mappings, very easy. They can be complex, introducing rules, maybe sometimes even exploring larger expressivities of the OWL, for example. So what is your expectation for most of the use cases that we have at hand?
That is actually an excellent question, to which I don't think I can give you a straight answer, right? I think it needs to be based on use case. And my expectations, though, is that a lot of the cases are going to be extremely simple for basic interoperability, because you will have these one-to-one mappings that you can do with different metadata schema that will help already. And then for the complex ones, of course, we need to take them into consideration, because at some point, if you really want to achieve full semantic interoperability, you will have to use rule logics and so on. But not all the communities are ready for that. It's really hard to use, hard to implement. And also it has a huge computational cost. So we need to find this balance in EOSC to achieve them on the use cases.
Well, I think that we have time for another question. Okay, the cough is calling, yeah, you're right. Please, Baptiste.
So I'm a small participant of the Fair Impact project, but I have a question about this semantic analyzer. I've been following for some time the iAdopt framework, and I'd be very interested to see how we can implement it, because for the astronomy group, I would be interested to explore that.
I would love to tell you more. Oops, yeah.
Okay.
Just maybe an additional remark on that, just Baptiste, to rebound on your question. I mean, defining standards, including for specific aspect of ontology, pattern of ontology, in that case, define scientific variables, is also super important. There, after we develop portals, we develop those semantic artifact catalogs, in our case, the onto-portal ones, and if we don't have a standard to follow and then implement by default behavior in the UI and in the API, then we don't know what to follow. So it's easy with OWL. For 20 years, we have OWL, and it's been standard. SCOS is also a standard. We can rely on it, although it enables a little bit more flexibility, and sometimes we need interpretation of that. And so we don't have any standard way of, until the work with the iAdopt program. There was a couple of others, but I really encourage now people to look at those kind of things, because now that we have an iAdopt way of representing scientific variables, in AgroPortal or in OntoPortal, we're already looking into designing specific UI and services that would say, oh, if you have encoded in Oscar thesaurus, for example, which is one example, your scientific variable using iAdopt, then we'll parse them and display them the right way, and then serve them with our APIs the right way.
Thank you. There is a question that is quite interesting here on the Slido concerning governance, and I would like just to where is now is? And the second one, perfect. Community agreement is essential. Who is able, legitimate for organizing this crossword validation? Probably Dan or Susanna.
Sorry, I was tweeting, so I'm afraid
You're right.
I didn't even read the question, that's why I apologize. Community agreement is a central organization of, so is there governance question behind? Who is able to, yeah, that's interesting. So who is the authority? That's another big question. Unfortunately, it seems that each community see their own community as the authority. You can have an ISO standard, but doesn't mean that the research community uses it. Sorry, yeah, like I said, you can have an ISO standard, but doesn't mean that sometimes the research community uses that. Again, for all the problem we illustrate, sometimes the difficulties of expanding, of enlarging, of change, or making the changes. So frankly, I don't have the answer. The authority are different from the different community. Yeah.
Can I ask a question? What is actually meant then with authority? I see it more as there is a egalitarian landscape of researchers that can collaborate, that can reuse one another's mappings and crosswalks, and that leave their fingerprint, of course, from I did it, and I did it for this and this reason. Now, it might well be that there are some organizations, for instance, those that maintain serif, for instance, and that are, let's say, that are certifying that certain crosswalks of them have been tested and can be used for this. But that's, I think, a different purpose than what researchers would like to use here. I think they're more interested in they would be interested, of course, in a certified serif crosswalk, but they're more interested, I think, in the possibility to have the flexibility to collaborate how they want and to put these new, reused crosswalks in the registry and make them available for further sharing.
Yes, Volmer.
Thank you. I think it's probably time to wrap up a little bit, but I mean, we have the EOSC Semantic Interoperability Task Force, and you're free to reach out. There is an open survey, and Kurt Baumann is happy to receive your responses. There's also this shared references document from the website with the program. You can click the link and add suggestions for activities that we should follow and that you would like to highlight for others who are interested in this topic. And I mean, we are EOSC, which means that how do we check semantics in EOSC is something that we need to figure out. And I think highlighting these kind of within community solutions and from projects actually trying to work with large data and map them is good ways of starting that discussion and highlighting some use cases that would be beneficial for discipline-specific queries. Because otherwise you might end up just having these administrative type of queries, which is not very motivational for a lot of researchers, I think.
I think that is perfect. Thank you very much to all the panelists. Thank you to you for having attended this meeting. Thank you.